Okay, the first thing I want to point out on this assignment sheet is Wednesday. So this Wednesday, I have to give the AP English exam. So I will not be in here at all. You guys won't be in this room. Now, out of habit, if you're anything like me, you will probably head towards this room without thinking on Wednesday. And when you do, somebody's going to go, you can't come up here, there's AP testing. And then you'll remember, they might even have the door taped off or something like that. But you won't be able to come in this whole hall. So if you have other classes in here too, they're going to be moved. So you got to figure out where they're moved to. We're going to be in our old room, in 206. So instead of coming here, and that's true for this Wednesday and the following Wednesday. So when you come in there, I won't be in there. Obviously, we're not going to have a lesson. I'm going to miss this class and probably all, if not most, of 5th as well, which is the other class. So just bring your exam review sheet or anything else you want to work on. It doesn't really matter to me. It'd be a great time to bring your exam review, and just because you could talk about that, ask questions about that, get something done. But definitely note that on Wednesday you are not in this room. And then the following Wednesday, just you might make a note as well on the 12th. I did not put anything in there about that. But on the following Wednesday, May 12th, we won't be in here either. We'll be back in room 206 again because they're doing AP testing. And I'll try to remember to mention that to you. But anyway, and then so you can see our test. Right now, it's probably looking like the 17th of May. And then all we have left after the 17th is that Tuesday, Wednesday, Thursday, Friday. And that Tuesday, Wednesday, Thursday, Friday right there rolls into the next Monday is the first exam. So we would be reviewing probably that Tuesday, Wednesday, Thursday, Friday. There's a chance on Tuesday, since we've already, at this point, we're going to have 2 review days already built in. We've had that one when I was absent. We'll have this one on Wednesday. Normally, I only give 3 review days, period. Right now, as it stands, it looks like 6. Which is way more than I think that's really necessary. There's a chance on Tuesday I might do some stuff with piecewise functions just to make sure you have an understanding of what they are in case you don't take this class again. I'm not worried about you if you do take the class again because you'll have plenty. But if you don't and you go to another class, I want to make sure that if they just jump in the middle of it, that you'll be comfortable with whatever they're doing, which most people say they're bored to tears in pre-cal. I had a girl in my AP Cal class today who took this class as a 10th grader and then took regular pre-cal, said, I truly believe I didn't learn anything new the entire year. Like everything was already been covered in this class, which makes for an easy year. Probably hurts maybe a little bit when it comes to AP, like ACT testing, stuff like that. But if you've struggled mightily in this class for whatever reason, it might be a nice year to get your feet under you or whatever. But you'll have to figure that out. But today we're starting counting principles. And the reason why I'm going to start with counting is you will see with probability, the definition of probability is essentially something to the tune of the number of ways that something could occur in a specific way divided by the number of ways it could just occur in general. You think about flipping a coin. If I want to know what's the probability of getting ahead, if I flip a coin, what's the number of ways you could get ahead? 1, divided by the total number of ways you could get outcomes, heads or tails. 2. Now, it's pretty easy to count the number of ways to get ahead. It's pretty easy to count the number of ways that a coin could flip. It's pretty easy to count the number of ways a dice could be rolled because it usually has 6 faces unless you're playing with some crazy looking die or in D&D or whatever. Point is, it's not always that easy. So sometimes the number of ways to do something can be very complicated. Like for instance, if I'm trying to calculate, like the person who invented cards or poker, there's a reason why a straight flush is a tougher hand to get, or why it's the best hand. It's the best hand because it's tougher to get a straight flush, which some people call a royal flush if it happens to be ace high, but it's tougher to get a straight flush than it is to get a full house. But a full house is still great. And the reason why it's a better hand than a lot of other hands is it's tougher to get it because somebody's gone in there and counted the number of ways to get a full house or a straight flush over the number of ways to get in all the other hands combined. And to be able to do that, we got to be able to count. So not counting like 1, 2, 3, 4, 5, but being able to count the number of ways things can happen. That's what we're starting now. Now, let me caution you in this chapter. If you're looking at your assignment sheet, you're looking to say things like complete the problems we skipped for homework. We're not going to skip a lot of them. You're going to feel over the next 2, 3, 4 days, whatever, that the homework's really not overly difficult. Some of the problems might give you a little trouble. It's very easy to look at the key, figure out what the key's saying, or not even figure it out and just copy stuff down and turn it in. And the reason I'm saying this is I took a probability class in college. And when I took that probability class, it was a quarter, we were back in the quarter system. So I went through probably the first 8, 9 weeks of the quarter, and it was a joke to me. I didn't have to do the homework. I was making highs on all the tests. Why? Because I was pretty logical, as you are. I was pretty analytical, as you are. And I was able to get by without learning all of the formulas, without thinking about all the processes. I could outthink the problems. And then I hit a point where I couldn't do it anymore. Like I couldn't tangibly write down the options. I had to be able to go back to the theory. And I was 9 weeks in and didn't know it. And the last 2 weeks were really troublesome for me to hold on to an A because I'd just gotten a little cocky. So it's very easy for you guys, because you're smart people, to depend on your common sense. But I really want to be talking about not only the common sense approach to it, but kind of a combinations, permutations approach to it, which we'll get into, and help you to see that there's 2 ways to kind of think through these. So when it gets too difficult for you to actually count, like for instance, I guess what I'm saying is this, like, what if I were to say, hey, how many ways could you arrange the letters A, B, C? Well, it wouldn't be that hard to go, well, I could go A, B, C, I could go A, C, D. I could go B, A, C, I could go B, C, A. I could go C, A, B, I could go C, B, A. And you could count those 6 ways, couldn't you? But if I say how many ways can you arrange the letters in the alphabet, that becomes a much more tricky task. And I don't have enough time today to write down all of those different outcomes. And even if I tried, I'd probably forget some or miss some. So we have to have a better way to count than just depending on our good common sense. Are y'all with me on this? So really force yourself in the early times to ask a lot of questions if you're confused, and to make sure that you're understanding the actual theory behind what I'm saying, and not just depending on good common sense, because it can start to fail you when things are not so concrete. All right. So what I'm doing, I'm sitting here at the counting principles page. All right. And this is on page 85. And we're going to start with the very basic, what we just said. Very basic start is talking about what probability is. And this is kind of what's going to start driving us, is towards an understanding of probability. But before we're going to get into this probability of an event occurring, like for instance, probability of getting a odd number if I roll a dice is the number of ways I could roll an odd number. There's 3, right? 1 through 5. Number of ways over the total number of ways of rolling a die, which is 1, 2, 3, 4, 5, 6, right? And I'd say, well, the probability is 3 out of 6. But it's not always so easy to count those. So in the idea of being able to count, to be able to determine probability, we got to be able to count. And it's going to start right here with this fundamental counting principle. Now, this fundamental counting principle is not rocket science. It's a very basic understanding, which you may already have, but I'm going to point back to it a lot. And essentially, the counting principle is talking about 2 events, but it could be 2 or 5 or 10 or any number of them. But it basically says, let's just pretend we have 2 separate events. And the easiest way to describe this would be like flipping a coin, right? Rolling a die. Let's just say those were our 2 events. And I want to know how many different ways could that happen? Like flipping a coin, rolling a die. And I don't mean like physically, like, well, I could flip it with my thumb, or I could, throw it off my elbow. I'm talking about the outcomes, right? So when we look at this situation, the fundamental counting principle says, if I want to count the number of ways to do this and this, and the key word is and I'm not always going to use the word and, but it's suggested and. Like when you read something, we're talking about doing this and this, as opposed to this or this. If you find yourself in a situation where you're hearing the word and spoken through the problem, whether they use the word and or not, okay, then what it says, if I want to find the total, I take the number of ways the first thing could happen, the number of ways the second thing that could happen, and I'm going to multiply them together. So if I want to know how many ways or how many different outcomes could occur if I roll a die and flip a coin, I don't have to write them all out. I can go, oh, it's 2 times 6 is 12. Are you with me? And I can use that same kind of logic in so many different ways. And a lot of our factorial applications, and you know what a factorial is, like if I say 6 factorial, it's 6 times 5 times 4 times 3 times 2 times 1. That's kind of like me saying, hey, let's just say you have 6 letters, 6 unique letters. They're all different. And I say, how many different outcomes or how many different spellings can you do if you used all 6 letters, each letter only once? And if you did that, well, how many options do you have on your first choice? 6. And once you pick that letter, now how many options do I have in that second choice? 5. And then once you pick that one, then 4, and then 3, and then 2, and then 1, right? Well, that's an example of the fundamental counting principle. You had 6 different things that you had to do, right? I had to pick 6 different letters for my words. And I was only given 6 to choose from. So I took those 6 and I actually found out how many different outcomes I could make by multiplying the choices together. Because once I make a choice, I have one less option there. So that's kind of like an example of how the fundamental counting principle works. Now, if you find yourself in a situation where the word is or, like, hey, how many ways can you pick a king or a queen? Well, in an or situation, you're really just doing one or the other, right? So I'm really only picking one card. But now that's different. That's not a fundamental counting principle because I'm not picking a king and a queen, which there would be 4 times 4 situations, which would be 16 different ways I could pick a king and a queen. If I say or, what do you think I'm doing? I'm adding. And you might have talked about this with teachers prior to me, whether it was Coley or Tyree. I'm not sure, but I usually have people say, they usually in this class go, oh, yeah, if it's or, you add, and if it's and, you multiply. So I feel like maybe somebody has spoken this into you before, but if they haven't, no worries. Practice will make better. And I am going to bludgeon you with practice over the next 2 weeks. You're going to do, if you look towards the end, literally, when I say probability part 1, part 2, part 3, some of the problems are different, but this is like 3 review sheets. And then I'm going to do review probability and counting. That's like a 4th review sheet. Then I'm going to do probability and counting. That's a 5th review sheet. Then I'm going to do probability. That's a 6th review sheet. So you're going to have all of that on top of all the other stuff we talk about. You will be very versed in the kinds of problems that you will see. Doesn't mean it's always easy, but you should be in pretty good shape by the time you walk out of here probability-wise. And you guys are the last group to ever have this current Algebra 2 style class. The course of study all changes next year. So they're actually infusing a lot more probability into this course. So other classes will get more caught up to where we've always been. But you guys get more probability than anybody teaches in high school other than maybe like a Hoover or a Stave or whatever math team class. Because I really push the envelope on what I'm able to teach you. I mean, I really have done lots of research to make sure I teach you basically up to the level that my brain can manage. And beyond that, I probably need to take a probability class, but you're really going to get a lot. So anyway, let's talk about the fundamental counting principle, some really basic ways it's used. And I have no idea where I will finish today. We're just going to plug through these. If I skip a problem, that's your homework. Go back and fill it in. The keys are up on Schoology. If something's wrong or missing or whatever, let me know. But let's just start with this. So how many ways by the way, a couple of words I'm going to be talking about that are really key and you got to start focusing in on are things like with replacement, no replacement. And then, so with replacement means, if I go back to that example about creating words from these 6 letters, with replacement would suggest what? Anybody got an idea? You can reuse it. Now, sometimes a problem is understood to not have replacement, just on the nature of the problem. Sometimes it's understood to always have replacement. Like if I flip a coin, do I go, oh, I used up the head. The next flip must certainly be a tail, right? Or do I roll a die and go, oh, I rolled a 3. Never going to roll a 3 again. I've already used that up. No, every time I roll it, I have the complete array of options, don't I? That's kind of like a situation where your options have been replaced. But sometimes it's a little different, like drawing cards. if I draw a card from a deck of cards, if I keep that card, obviously in my next choice, it's not in there, right? If I draw out an ace of spades and I'm holding that, my next choice is not going to be an ace of spades. But if I replace it, right, and mix them back up again, now it's an option again. So you need to look for words like with replacement, no replacement, or understand the kind of problem that it is. Because sometimes when you're playing cards, and if you're playing poker with your friends, are you playing when you're playing with replacement or with no replacement? If you're playing a hearts, any card game with your friends, no replacement in that hand, right? You don't go, oh, I got an 8, put it back in there. Oh, I had an 8 from earlier, but I'm just going to put it back in the deck. That's not how you play. So some games won't specify that. You just got to get used to it as we're going through the deck. Going through this work and understand what kind of situations fit, because I'm not going to change things up on the test. You're going to go with what we've been typically doing, or I'm going to be very specific when I say things like this. All right? Okay. And I'm also going to mention 2 words called independent and dependent, and they're going to be tied to these words. Okay? So let me ask you a question. Do you think this is independent or dependent? An independent or dependent event? I know I haven't given you a definition. All right? But if I choose a card and look at it, right, and keep it, do you think the next choice is independent or dependent? It's a dependent event because it depended on what I just did, right? Are you following me? That choice I made had an effect on the next outcome. That's a dependent event. Now, if I flip a coin, right, and I get it in its tails, the next time I flip a coin, do you think that is independent or dependent of what just happened? It's an independent event because it didn't depend. Ironically, if you ever go to Vegas and you're playing the craps tables, you'll see a lot of, or craps, or the roulette wheel. If you're playing roulette, where they spin the thing and then the little marble lands on a certain coin. They have these little digital towers, or they're probably not digital anymore. It's been a while since I've been to Vegas, but and I'm not a big fan of Vegas, unless you want to go to shows and hear whatever. It's really kind of a depressing little whatever. Anyway, they have these little towers, and these towers show all the prior numbers that landed. So like, literally, if a 10 comes up on the roulette wheel, you'll see a 10. And if the next one's an 8, the 10 will rise up and there'll be an 8. It'll show you like the last 8 outcomes. Why? It's an illusion. Yeah, it makes people think, oh, a 10. What are the chances of the 10 showing up? Yeah, it just showed up. The same as it always was, because you're spinning a wheel and it's completely independent of what happened before. But people are stupid, right? And they're banking on people that go to Vegas, at least. I mean, look in the country. Somebody said one of the more depressing things is they look around the country and they said, like, half of our country. No, they said the average citizen. I'm sorry, what did they say? Half of our country is. I'm on video. I gotta be careful here. Half of our country is a bunch of morons. But that's saying that's the average American. It's really quite depressing when you start looking at it. But a lot of people go to Vegas. Some of them understand the math. Some of them just have a good time, don't care. I saw a guy once, this was in 1993 when money was worth a lot more now, dropping $10,000 a hand playing blackjack. And I watched him lose $30,000 before he won a hand. He just lost. And when he won, he just looked over his wife and they're like, hey, little high five. I'm like, dude, you just lost my salary in 1994 or whatever year it was. It was amazing. Like, people just go there and they don't care. But anyway, point is, there's a difference between independent and dependent. So understand there's a connection here. If I am replacing something, putting it back in there, it means that the next hand is what? Or the next choice is what? Independent or dependent? With replacement. Like, so if I say I drew a card and then I put it back in there, the next choice would be what? Independent of the first choice. So when you see with replacement, think, oh, wait a minute, those are independent events. They don't depend on what just happened because it's right back to where you started. But if I'm not replacing it, right, if I'm drawing a card and keeping it. Are you with me? Or if I'm on a weird roulette wheel where every time the number is drawn, I put a block there and it can't be chosen again. If there's some situation which forces the next option to be different, that's a dependent event. We're going to talk about that more specifically. But anyway, let's just talk about some of these. This first one says, how many ways can two letters from our alphabet be chosen from the English alphabet? And if I just use them, it says with replacement, it says I can reuse the letters. So how many different ways could I do that? Think about the fundamental counting principle. Shouldn't be too tough. What do you got? How many ways, different words or whatever, could really be a word, could not be a word. How many different ways can I create two-letter things if I pick two letters from the alphabet? Yeah, the first choice, you got 26 options. A choice, and I made another choice, right? And when you see that word and, that's suggesting fundamental counting principle, 26 times 26. And by the way, we are not going to multiply this stuff out. So we're going to set it all up. There are going to be very few problems on this test where I'm going to ask for an exact answer because they're going to be awful to type in your calculator or whatever. So we're not going to do that. We're just going to do the setup and leave it. And there are multiple ways you can set things up. We'll talk about all those as well. Y'all with me? Now on this one, no replacement. So every time I pick a letter, I can't reuse it. What do I have here? 26, and then once I pick it, down to 25. And if I kept picking, you would see it keep decreasing, wouldn't it? That's kind of starts looking like a factorial, doesn't it? 26, 25, 24. When you see situations like this, which are dependent events, you are going to be able to start using permutations and combinations. We'll talk more about those shortly, maybe today, maybe tomorrow. But you're going to be able to start doing these without just thinking through them individually. You'll be able to do things like, oh, 26P2. And you'll see that that represents the first two numbers in a 26 factorial. And that's what you have right here. So we're going to start learning how to do this kind of stuff and get symbols or expressions that represent this. As we move through there, you'll see these more and more. All right, what about this? 8 pieces of paper numbered 1 to 8. 2 are drawn with replacement. With replacement, what are we doing? Putting it back, right? Sorry. I skipped one. Sorry. Right here. How many telephone numbers can be assigned to each area code? So, sorry, whatever I was just doing. It says the first number after the area code can't be a 0 or 1. So for whatever area code we're talking about, I can't, we know that phone numbers in this state right now, or this country right now, other than the area code, are 7-digit numbers, right? Used to be 5. Before that, it was like you push a button and the local operator would come on and you go, Sarah, connect me to Bill or whatever. And they would just do the little plugs like you see on the Andy Griffith show or whatever. But now we've got 7-digit numbers, not counting the area code. So it said the first number can't be a 0 or 1. So if it can't be a 0 or 1, then how many different options do I have for that first number? I've got 8. All right, now this said with replacement. So if the first number can't be a 0 or 1, there's 8 options, right? Because your options are 0 through 9. All right, so the second number could be what? There's any of those 10 numbers, right? 1 through 9 and 0. So there's 10 numbers that can be right there. So 8 times 10, and then the next one? 10, and the next one. And I can do 10 for all of these. That's not a minus. That's just a little dash for the phone number. So in each option, in this situation, I'm going to end up with, what, 8 million different phone numbers I could make if I can use any number more than once, as long as the first number is not a 0 or 1. You guys live in a different world. It used to be, nowadays, you always type in an area code. You don't even think about it. You just type in just click on your friend's name on your phone or whatever. But it used to be, if you lived in Birmingham, you didn't have to do an area code. You just dialed the number and it just assumed you were in this area code and you had to do it. Now you have to dial an area code. That changed just recently, where you have to type in 205 blah 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 if you want to get somebody's phone. But again, it doesn't really affect you because that's how you just grew up raising. Once it's in your phone, you just hit a button. I don't even know my kids' phone numbers. Honest to goodness, I have no idea. If the world were to end, but phones would stay alive or whatever, or if my phone went blank, I have no way to call them other than I really ought to remember them. I know my wife's, mine, My parents, because they've had it for 40 years. I don't know that I know anyone else's at all. My wife's I'll never forget because her name's Gina and it's 585 Gina. Again, my parents have had it since I was 18 years old. But I don't remember them. I just click a button. But it used to be a little different. But there would be 8 million options right there. And it used to be 205 was the whole, I think it was 205. What's Montgomery? Anybody know Montgomery? I think 205 was the whole state of Alabama at one point because people didn't have cell phones. You have one phone number a family. And then they went to 205 and 334. I think 334 is Montgomery maybe, or used to be, or I don't even know. But now there's like a dozen of them all over the place in this state because everybody has a phone. People still have some landlines, work phones, all that kind of stuff. All right, what about no replacement? What changes? So I have 8 for the first option. That's this. But if I have still 8 right here, but if I'm not going to replace it, that means once I use it, I can't use it again. So how many options do I have for my second choice? I have 9, don't I? Right? Because I have 8 on this one because I couldn't use the 0, 1. But now I can use the 0, 1. I just can't use what? Whatever I just chose, whether it's an 8 or a 5 or whatever, right? So there's still, I've only used 1, so now there's 9 options left. But now once I use that, what's left? And then, right, all the way down. So you can still see that factorial showing up right there from the 9 on down. Why? Because it is a dependent event. And dependent events that depend on what happened in the first choice are going to almost exclusively fall into that permutation combination stage. So what I could have done on this one, even though it doesn't make a lot of sense to you now, I really had one number that I chose, right? I had to pick one number from those 8 that were available. That's like doing an 8P1. I couldn't use 0s and 1s, but I could use any of the other 8. So I chose one of those 8. And then the last one, I said, well, now I have 6 numbers left, and I'm going to choose 6 from the remaining 9. This ends up being 9P6. And you're going to have to learn to think this way, this 9P6. Because again, right here, not hard. But it would be more difficult if I said, hey, guys, how many different 200-digit codes could you have if under these conditions? Do you really want to write out 200 blanks and write these numbers in? No. So I want you to be able to learn a little bit better than just being able to eyeball it and think through it manually or concretely. Think more abstractly. And don't be bothered by these P's and C's right now. We'll get to those shortly. All right, what about 8 pieces of paper are numbered 1 through 8? So just visualize that, right? Got 8. You're drawing 2 of them. How many different ways can you get a sum of 12? Now, sometimes things you're just going to have to be very concrete with it and visualize it. Sums of 12 occur how? By adding, right, you could get a 6 and a 6, right? So that's an option, except I don't have, if they're only numbered 1 through 8, can I even get a 6 and a 6? There's only 1 6 out there, right? So what are your options? 6 and a 6 won't.
Yeah, it is with replacement.
Oh, with replacement, sorry, yeah. So you could do a 6 and a 6? Sorry about that, yeah, with replacement. A 6 and a 6 would work, what else? 7 and a 5, or what? I could draw the 7, put it back and draw the 5, or I could draw the 5, put it back and draw the 7, right? So actually, there are 2 different ways that could happen. 4 and 8, and then 8 and 4. Anything else? So if the question was, how many different ways could a sum of 12 be obtained? You've got 5 different ways that could actually happen. And I'm not going to go 6 and 6 and 6 and 6 because that's literally the same thing, right? But drawing a 7, putting it back, drawing a 5, that is a different outcome. It's a different way for that to occur. And if I'm getting the probability, eventually I'm going to have to ask myself tough questions like, well, what's the probability of getting a sum of 12 if I draw 2? And I would find the number of ways this could happen. I would find the number of ways anything could happen. And I would have that fraction that would enable me to do probability. What about license plates? I don't know. License plates used to have a really consistent rhyme or reason to them. Like the first digit was always the number of the county you lived in. And then there was a couple letters in there. but it could be any. I've seen so many different variations now, I don't even know what's going on. So we're going to go with this. How many different license plates can you have for Jefferson County, which is where you guys live, if the first digit is a 1, right? So the first digit has to be a 1. So we're going to put a 1 right there. You have no options right there. It says the next 2 digits are letters. So your next 2 digits are going to have to be letters right there. And then the next 3 digits are numbers. So you've got a letter, a number, a number, a number, and then the last digit was a letter. So at one point, this was actually how it worked in Jefferson County, or the state of Alabama. But there were no O's, I's, or Q's. You know why? Because I's look like 1s for a cop that's chasing you or whatever, and O's and Q's kind of look the same. So it looked like 0s. So there were no O's, letter O, I's, or Q's as options. Now, that may or may not be true. It actually was at one point for this state. I'm pretty sure that's true unless you have a specialized plate. But we're going to go with the problem and just do what it says. So based on that, with replacement, how many options do I have for the first letter? 23, because I can't have those 3 and there's 26. So there's 23 letters, but I can replace it. So how many options do I have for the second letter? Also 23. How many options do I have for the numbers? 10, so 10 times 10 times 10. And then for the last letter, 23. So if I wanted to know how many different license plates I could have, this first one wasn't even an option. I didn't put a 1 there because I said it was a 1. I put a 1 because there was one option for that, which was 1, right? But there's 23 times 23 times 23, which is a fairly decent sized number, times 10 times 10 times 10. That's how many ways I could do license plates if I can reuse letters and numbers. Now, what if I'm saying no replacement? Then what do I have? I've got 23 options for that first letter, but then 22, and then what about the numbers? Then 10, then 9, then 8, and then for the last letter, 21. So really, if I want to know how many ways I could do that, what I'm really doing is saying, how many ways can I pick 3 letters and 3 numbers? And I can count that really efficiently by saying, well, there's 23 letters to pick. I'm going to be picking 3 of them, that one, and that one. And there's 3 numbers to pick from those 10. I'm going to be picking 3 of those. And that, to me, is a much more efficient way of getting this value. What I do.
Well, why wouldn't the first number be 9 since you already used it?
Yeah, that's absolutely.
It's like,
Oh. No, that's a good point. The first digit is a 1.
It doesn't really specify if that's counting.
but it says no replacement.
Yeah, it does say no replacement. So, it's a good point. I wasn't even thinking about that first digit. 987. So if that's already off the table, if the 1 was off the table, then you have 9 letters left, 9P3. So this is kind of where I want you to end up thinking. And again, you don't even know what a permutation is necessarily right now, so don't worry about that. But I don't want you to get in the habit of going, oh, I can just write these out. Because there's going to come a point where it's too ugly to just write them out. And if you're not versed on the actual fundamentals of what's going on and the theory behind what's going on, it's going to be hard to get that at the last second. What do I got, 10 minutes? Yes. Okay. So permutations. Here we are, permutation. Okay, so permutations. Every year I think about getting rid of this part of the section. But permutations are important for you to understand the difference between a permutation and a combination. It's a very big thing for you. Most people get this down, but occasionally there's still somebody on the test who messes it up. And the reason why I think they get it messed up is the world messed it up for you. Right? You've probably heard of a combination lock, right? A combination lock is not a combination lock. A combination lock is a permutation lock, okay? Because a combination says that when you're counting the order, the number of ways to do something, the order in which it's done has no effect on the outcome. That's a combination. When you're playing cards, like if I walk up to Holden and I hand him the ace of spades, the 10 of spades, and the jack of spades, and then the king of spades, and then the queen of spades, he's not, oh man, he gave me all these spades, but he didn't give them to me in the right order. That's not what Holden do. Holden's going ace, king, queen, jack, 10. and he's pushing all in, or he's going to bait me into some bet because he knows he has the best hand of the day, right? The order in which I dealt him those 5 cards did not have an effect on the outcome. They didn't matter what order I gave it to him. And if a combination lock really was a combination lock, then the order in which you dialed your number wouldn't matter. Are you with me? It wouldn't. Like if my number was 0624, then I could dial it 0624, I could dial it 2460, 2406. It would not have an effect on the outcome. So your combination lock really isn't a combination lock. It's a permutation lock. Because on a permutation, the order in which something done does have an effect on the outcome. Have you ever played war, like when you're a kid with cards? Let's just say you had a king, a queen, and a jack, right? And you played a king, and the other guy played an ace. What just happened? You lost. And then you threw your queen down, and you didn't know because you had been just whatever. You were just blindly flipping, right? And when you threw your queen down, he had a king. You lost. You lost. Okay? And then you threw a jack down, he threw a queen down. You lost again, right? But what if the order was different? What if your order was, what did I say you had? Queen, jack, king? If I had this, you might have still lost that and that, but you would have won that, right? Or what if hold on. What do I want to do here? Queen, jack. Oh gosh, I don't know. King, queen, we'll say that. If you had this, you would have lost here, but you would have tied on that. And you remember what happens with a tie? Don't you like take 3 and then flip them? So a totally different outcome could have occurred. The game could have been completely different. So in a situation like this, clearly the order in which your cards were played had an effect on the outcome, right? That's a permutation. So you have to ask yourself in situations, is something a permutation or is it a combination? Because if it's a permutation, you're going to use a permutation formula. Now, this is a very specific, not a general permutation formula. I'll give you the general one next, all right? But if it's a combination and you use a C, totally different formula, okay? So let me quickly, I've been writing permutations up here on the board. Let me give you this definition real quickly. This one's very generic. It says MPN. Again, probably shouldn't even have put it on there. So I'm going to scroll down a little bit to the actual permutation formula, which is on page 87. And if you look at 87, it's NPR. Some of you are already going to know this. If you see NPR, what that's saying, mathematically what it's saying is, take the first number that's on the left, make it a factorial, and put it on the top. It is not saying take the second number, make it a factorial, and put it on the bottom. It is saying subtract those 2 numbers and make a factorial out of that on the bottom. But you know what it's really doing? When I do something like 10p7, it's telling me to take the first number factorial on the top, subtract, which gives me 3 factorial on the bottom. But when I write that out, and you've done a little of this, because when we were doing like the nth term and an expansion, you did some of this. What am I left with here? If I were to write out 10 factorial and 3 factorial, what doesn't cancel? Everything all the way on down to right before the 3, right? Because the 3, 2, 1 cancels. Isn't this the first 7 numbers in 10 factorial? Right? So if I'm doing something like, oh yeah, back to the license plates, and I'm looking at this and I'm going, all right, there's 23 different letters here, and then there's 22 there, and then there's 21 there. It's not hard to do that. But isn't that the first 3 numbers in 23 factorial? That is the same thing as 23p3. Or what if I had to fill in all the other numbers and go like, all right, the rest of the license plate, let's just say there were 5 digits. You know, that's, let's just say it was 10. 10, 9, 8, 7, 6. That's not that hard when there's only 5. But what is that the same as? That's the first 5 numbers in what? 10 factorial. That's 10p5. So there are quicker, more efficient ways of writing stuff like that. But the bottom line is when you're looking at a permutation, you have to ask yourself the question, as I am counting in this particular problem, does the order in which I do something have an effect on the outcome? Here's two great examples. I need 10 of you guys to help me lay sod in my front yard. All right? I need 10 of you. And I'll pay you and feed you ribeyes for lunch. Now, if I said that, you'd be like, yeah, why not? Chill out at Mr. Hurry's house, check out where he lives, maybe I can roll him later, whatever. But you go over there, you come over there. Does it really matter if I go, hey, you, and you? Now, if I do that, is Abdul going, oh man, he picked me ninth? No, because it didn't matter the order in which I chose them, did it? Right? The outcome wasn't affected. Now, what if I said this? Hey, I need to pick a lineup for kickball. We're competing against Mr. Helmers, and I need, whatever, and I go, all right, I want to pick you, and you. And it turns out Abdul has the golden foot, man. He's like he can kick it a mile, he's going yard every time he kicks. Do I really want him going last in my order? Now, I don't know what the best place for a kickball lineup is, but in baseball, you tend to want your power in the 4 and the 5 hole, right? So the order in which I chose that lineup, could that affect my outcome? Yes. So you got to ask things like if the order, and sometimes it's vague. Sometimes you're like, Mr. Hurry, it's kickball, man. It doesn't matter. We're just going and having a fun game. Well, it depends. And sometimes it could go either way. But you got to ask yourself that question when you're counting, because if you're starting to use P's and C's, we'll talk about combinations later, it's really important that you understand what you're dealing with. Because if I start using C's, well, it's a different formula, right? And it's very vague sometimes. Now, what if these two numbers are the same? Like, what if it's 6p6? Well, what is 6p6? It's the first 6 numbers in 6 factorial. What does that sound like? Sounds like 6 factorial. So if you ever are going to use all the numbers, you can use this if you want. But look, 6 factorial over 6 minus 6. By the way, what is 0 factorial? It's defined as 1. There's a reason. You can look into it, whatever. But that just ends up giving me 6 factorial. So if you see that it's a factorial, you don't have to use a permutation. But if you see that that number is any less than that, remember what it actually means. And it can help simplify some of the process that you're going through. That's about all the time we have. I don't even know if we skipped anything. Probably didn't. If we did, fill it in. If not, we'll pick up with this tomorrow. And y'all have a good one. Yeah.
So if I go tomorrow, can you guys go to the library?
Yes. Media Center Tuesday, Thursday. Miss Parker's room on Monday and Friday morning. So soccer people, y'all are missing Friday, I'm guessing, all day?
Yep.
You know who you're playing first round?
Southside guys.
You played them before?
How'd it go?
We won 6-1, but they've gotten a lot better.
Who's left? You, Southside?
Someone else.
Is that Mobile?
I'm not sure, but they beat me this one, so they should be pretty good.
You don't know who else?
Pelham?
Oh, really?
I'm excited.
Nice.
Yep. See you later, Terry.
See you.